All right, so we're going to go over flowcharts. The idea is to create a flowchart to write computer programs that solve engineering problems and perform engineering simulations using common software tools. We're going to use MATLAB and Python in this class, and then Excel or any of that. So what is a flowchart? It's a means of visually presenting data in a way that'll take us from the start of the algorithm through the final of the algorithm. And an algorithm is a method for solving a problem. So if a problem can be solved, then an algorithm exists that could be written. Okay, this is really important. So that means that mathematically we should be able to represent pretty much everything into a simulation. And so just like a blueprint for a building, this is going to be our method of setting up for code. So what is the meaning of a flowchart? Well, it's a way of diagramming a process so that it can be visually oriented. It really facilitates communication between the programmers, the business people, as well as like maintenance people. Maintenance people are going to use these a lot. Or a technical person. So the engineer is really critical in putting these together correctly. And really they play a vital role in helping understand complicated problems. There's less and more common symbols. In our case, we're going to focus on the more common symbols. If you go into PowerPoint and you click on like insert and you see the shapes, you'll see a whole bunch of flowchart shapes are even marked as that. And if you have flowcharting software, you'll see it. And there's a standard to it, right? This hold on, ANSI standard. Okay. So when we get in here, I use an oval. This has like the rounded edges, but I use a straight up oval for the start and end of the program. A rectangle is a computational step or a process step. These parallelograms are input and output, and it's usually like a print output or whatever's being displayed. Use a diamond for like a decision. And then we won't really use connectors in here, but you could have a flow connector for inputting multiple flows. And then flow line would just be a straight kind of arrow one to the next, and that shows the process or the flow of data through it. The advantages of flowchart: it has better communication, and it's a better way of communicating logic. It has effective analysis. So with a flowchart, a problem can be analyzed in an effective way, and you'll see that a lot with different maintenance structures because you can just follow something that's step one, step two that was put together by an engineer, and it shows you how to go through it, and it's like magic to you. If you didn't know how to fix something, it'll walk you right through it. Proper documentation. So again, this just is good program documentation. It's a good way of showing people what you've done. It makes for efficient coding so that you don't have extra junk in the code. So sometimes when you're working out of examples that are online or something, they've got extra stuff in your code, and it could be a little nightmare. So this helps you phase down what you want. It could be that you've pulled in a package later on in life. As you get more advanced, you start pulling in packages, and it turns out you don't need all of this. So figuring out what is overhead, because that creates, erosion in the software processing. And then proper debugging, be able to debug something. And then maintenance, it's just huge to be able to have this. Major limitations: if you have really complex logic, this thing becomes a nightmare, and it's just clumsy, and then you have like a flowchart of a flowchart of a flowchart, and it's just not good. So that's not what you want. If I want to modify it, there is software out there now that does a lot of this, but like if I was just going to do this in PowerPoint and I just wanted to modify something, like you have to like redraw it. So it sucks on the spot if you don't have a good way to do it. Reproduction, again, it's just not always easy to reproduce a flow chart from one to the next. And then if I need to space save and do it differently, that's messy. and the essentials of what's actually done can be lost in technical details of the flowchart itself sometimes. So you really have to get used to this to be able to understand them. So here's just kind of a joke example, but it's a good example. You know, you go in and you say, "Hey, does this move?" And yes and no. Well, if it doesn't move and it's not supposed to move, you're done. Get a beer, right? If it does move, if it's supposed to move and it does move, then you're done again. But you know, if it moves and it's not supposed to, they say duct tape it. And if it doesn't move and it should, then WD-40 it. But it's a maintenance flow chart, right? This is an example. Okay. Here you go. Here's a real example. Now we're going to add up the first 50 numbers inside of a loop. Now I know those of you that took calculus, you know you can do like 1 plus 50 and 2 plus 49 and 3 plus 48, and you can multiply, 51 times 25, and you'd have the answer. I get that. Okay, that's a closed form solution. But as we get more complex, those closed form solutions are hard to get. So in this way, I would go down through this and I would start my algorithm. I start my sum with 0. I start my number with 0. And I move myself forward. So I move the number up 1 and then I add the sum to the previous sum. And I can print that because I want to show it inside of the loop. And then I ask, is n equal to 50? No, right now I'm at 1. So I go back around, let n equal 2. I add 2 plus 1, which is 3. I print 3. Then it goes back around. It says, no, we're not there. So we add 3, right? So, you know, we continue our way through this flowchart until we've cycled enough that we've added together all of them, and then we go ahead and end. Here's one where we have 3 numbers, and we want to sort them, and it's just a given 3 numbers. So the user gets to put in the 3 numbers, and what this is going to do is sort them for it. So you drop them in, and it just picks 2 of them. It says, okay, which one's bigger out of these 2, right? And if I just want the largest here, I can throw it away. If I want to sort these, then I got to recompare. So whatever's the biggest, if A is the biggest, I keep A. If B is the biggest, I keep B. And then I can compare those, and that'll show me which one's largest. And then if you want to sort these, there would be another layer that you would use. Okay, do you remember how to do this? So what I want you to do is go ahead and try the symbols. I've pitted you against each other, and then I want you to think about where are you going to use this in your future, and go ahead and type it into the text box. Okay, good luck.